Stop saying configured to in AI claims. Write precise English. Configured to sounds impressively precise, but in law and tech, it's a fog machine. Who actually does the thing? The system, the user, or the coder? The phrase rarely says. That ambiguity invites disputes, failed expectations, and shaky documentation. In AI, it's worse. Configured to can imply broad, magical abilities with no proof. Vague claims inflate risk, especially under audits, procurement reviews, and regulatory scrutiny. If a feature fails, you can't point to a clear mechanism or test. Let's replace vague setup talk with specific agents, conditions, and measurable outcomes you can verify. Start by naming the agent. Is it the model, a pre-processing module, the user, or a server task? Ambiguity dies when the actor is explicit. Next, state the condition. When it runs, where it runs, and with what data or context. Finally, specify the outcome as a measurable, testable result. For example, the inference service, agent, on receipt of a transaction payload, condition, computes a fraud score and writes a JSON record, outcome. If someone can run a test and confirm it, your claim is solid. Trade configured to for verbs that show behavior, executes, selects, sorts, classifies, outputs, logs, sends, rejects. Then tie each action to inputs, thresholds, or rules. Executes inference when payload size less than 1 megabyte, or outputs label if score is greater than or equal to 0.85. Use observable criteria, not intentions. Avoid aims to, tries to, or intended to. If a reviewer can't watch logs, inspect outputs, or measure thresholds, the verb is too soft. Make every sentence something a tester can verify or falsify. Strong claims live inside clear boundaries. Limit context. Specify domain, e.g., payments. Dataset, e.g., 2023-2024, labeled TXNS, and user role, e.g., analysts only. Include constraints like latency targets, accuracy ranges, and safety checks that must pass. Clarify triggers. Is the action started by an event, file uploaded, a schedule, hourly job, or an API call, post/score? Boundaries prevent overreach, align expectations, and simplify validation. If the claim doesn't say where it stops, assume it will be misread or misused. Spell out the components to make causality clear. The model, pre-processing, tokenization, normalization, and post-processing, thresholding, routing. Explain signals. Which features, prompts, or labels drive the result? Then describe the flow. Input right pointing arrow transform right pointing arrow decision, right pointing arrow log. Example: raw JSON, right pointing arrow feature. Encoding right pointing arrow model inference. Right pointing arrow score threshold. Right pointing arrow decision code. Right pointing arrow audit log. When reviewers can trace each step, they can test, debug, and trust the system. Opaque pipelines invite doubt. Transparent paths invite approval. Name the safeguards: content filters, rate limits, anomaly blocks, and human review gates. Quantify them. Set false positive caps, e.g., less than 2% monthly. Confidence bands, e.g., Act only if score is greater than or equal to 0.85 or drift thresholds. State fallback behavior on uncertainty. If confidence less than 0.6, route to human, do not auto-action. Include safety checks like PII redaction and prompt moderation. Clear safety language reduces legal exposure and operational surprises and shows you've designed for reality, not just demos. Weak. The model is configured to detect fraud. Who acts? When? Based on what? No one knows. Strong. Upon score greater than 0.85, the service flags the transaction and sends an alert to the risk queue. We can test that. Stronger. A BERT-based classifier scores transactions. If score greater than 0.85 and velocity greater than 3 sigma, the service queues the case for an analyst within 2 minutes and logs decision _id, score, and features. Each element is observable, time-bound, and falsifiable. Use this quick formula: agent plus condition plus action plus metric. Keep wording observable, testable, and falsifiable. Someone should be able to run it and prove you right or wrong. Define bounded scope, domain, users, data. List explicit safeguards, filters, thresholds, human in the loop, and require clear logs for audits. If a sentence feels like marketing, rewrite it as an experiment. Given X, the system does Y, measured by Z, within W seconds. That's how you turn risky promises into reliable, verifiable claims.